Ever wondered how big data can predict future trends? Picture this. Every day we generate quintillions of bytes of data, from social media posts to online transactions and even satellite images. This massive trove of data is what we call big data. As we navigate the digital landscape, big data has become a crucial player. It's like a vast ocean of information, holding secrets waiting to be discovered. But how do we make sense of it all? That's where predictive analytics comes into play. Predictive analytics is a method that sifts through this sea of data, analyzing current and historical facts to forecast future events or uncover unknown phenomena. It's like a crystal ball, powered by algorithms and statistical models that allows us to peek into the future. But it's not magic, it's pure science and mathematics. Now you may be asking, how does this process work exactly? Hold on to that curiosity. Predictive analytics in big data isn't magic. It's a meticulous process involving several steps. Let's delve into these steps one by one. First, we have defining the project. It's where we identify what we want to achieve. Whether it's predicting customer churn, forecasting sales, or detecting fraud, it's essential to have a clear goal in mind. Next, it's collecting data. This phase is all about gathering the necessary information to achieve our project goals. It could come from multiple sources like databases, weblogs, social media feeds, and more. Moving on, we reach the data analysis stage. Here, we clean the collected data, removing any irrelevant or erroneous information. Once we have a clean data set, we explore it, looking for patterns, trends, and relationships that could be useful for our predictive models. The fourth step is statistical analysis. This involves applying statistical techniques to the data to identify significant variables and relationships. Techniques may include regression, correlation, and time series analysis, among others. Then comes the exciting part, predictive modeling. Here we use machine learning algorithms to create models that can predict future outcomes based on historical data. We train these models with a portion of our data, then test them with the remaining data to see how accurately they can predict. The sixth step is deployment. This is where we put our predictive models to work. We integrate them into our business processes or systems, allowing them to provide real-time or near real-time predictions. Finally, we have model monitoring. Even after deployment, it's critical to monitor the model regularly to ensure it's performing as expected. If the model's accuracy decreases over time, it may need to be retrained with new data or adjusted. As you can see, predictive analytics is a systematic process, each step building upon the previous one. Predictive analytics isn't exclusive to a single industry, it has a wide array of applications. Let's take a closer look at some of these fields. In healthcare, predictive analytics can forecast the likelihood of a patient getting a disease, enabling early intervention. It can also predict patient readmission rates, helping hospitals optimize resources. In finance, predictive analytics is used to assess credit risks or to forecast stock market trends. It provides insights into potential financial outcomes, guiding decision-making for investments and risk management. In marketing, predictive analytics helps in understanding customer behavior, enabling marketers to create personalized campaigns and increase customer retention. It can predict buying habits, preferences, and even the likelihood of a customer churning. In manufacturing, it can predict machinery breakdowns, allowing for preventative maintenance, thereby reducing downtime and saving costs. From healthcare to finance, predictive analytics plays a crucial role in shaping our future. So, we've journeyed through the world of predictive analytics in big data. Let's recap what we've learned. We started by understanding predictive analytics as a statistical approach to predicting future events based on historical data. Big data, as we've seen, is a massive volume of data that's too large to process using traditional methods. We then walked through the step-by-step process of predictive analytics. This process starts with defining the project, then moves to data collection, data analysis, statistics, and finally, deployment. Each step is crucial to ensuring accurate predictions. We also explored the vast applications of predictive analytics in various fields. From healthcare to finance, predictive analytics helps organizations anticipate future trends and make informed decisions. Next time you hear about a company predicting future trends, you'll know the science behind it. That's the power of predictive analytics in big data.